Hello and welcome to a drive-by coding session. So Waikit is learning how to use the Canvas API. So he learns from using the documentation site at MDN Web Docs, which is an excellent resource for learning about Canvas and all things web browser JavaScript related. So Waikit likes TypeScript, and he uses this web template for TypeScript, where he downloads this zip file and then extracts it into the project. So, but before that, he first created git ignore files to tell Git not to commit the node modules. That's standard practice. And then he pastes in the files of the template. I'll show you a quick look around these files. There's an index.html file provided by the template. There's also an index.ts file. It's a bootstrap TypeScript file, which all it does is display the text it worked in the web document. There's a package.json, which contains all of the development dependencies that you need to run this app, including, most importantly, TypeScript and Webpack. There's a tsconfig, which is the TypeScript configuration file, and a Webpack configuration file. So in order to get this guy started, Waikit does npm install to have all the npm packages installed, and then he does npm start. So once you run npm start, it'll start off the Webpack dev server, and then you can see the app in the browser. And when you get started with the template, it just looks like this initially. But then you can get going by simply changing the index.html and index.ts files. All right, so let's see what Waikit does. So the first thing he does is just updating the title of the document. And then he goes in the index.ts file and creates a canvas element. TypeScript. So I'm going to not go in depth about TypeScript, because most of it is going to look like JavaScript. But TypeScript does give us some benefits, such as it'll tell us what is the type of the value that's held by a certain variable. So here it can tell us, oh, the canvas variable, it holds an HTML canvas element. Okay, the next thing Waikit does is set the width and the height of the canvas and then append it to the document body. And he gives it a border so that it's visible. We can see where the canvas is. Now we need to draw on the canvas. So Waikit creates this canvas. Let's ignore this line for the moment. So Waikit calls the canvas.getContext method in order to get a drawing context. It takes one parameter. So if we hover over the definition of this method, it's a bit much, but it tells you that it takes a context ID as a parameter, which can either be 2D or WebGL. WebGL is a more performant and more featureful way of drawing on a canvas. We're gonna use the 2D drawing context, which is simpler to learn. So perhaps in a future video, we can explore the WebGL. So So you first get a drawing context in order to draw, and then with the drawing context, you can use methods on it to draw certain things. So this fill rect method will fill a rectangle or draw a rectangle which is filled with a certain color. We can change its position. The way the coordinate system works is 0, 0 is the top left corner of the canvas, and then since our canvas is 500 pixels wide by 500 pixels tall, the bottom right corner of the canvas is going to be 500, 500. So 0, 0 on the top left, and then 500, 500 on the bottom right, and then the top right is going to be 500, 0, and then the bottom left is going to be 0, 500. So by this, the first parameter is the x coordinate of the rectangle. So and the second one is the y coordinate. So let me label these actually. X is 0, and then y is 100 currently. So the first two parameters are the x and y coordinates of the rectangle. In this case, it's actually a square, because the width and the height, the next two parameters are equal. We can move it around by changing the x and y coordinates. So change y to 0, then we'll get the square at the top left corner, starting at the top left corner. If we did 500, 500, then what would happen? Make your guess before it. Okay. Then we actually don't get to see the square because it's going to start drawing at this point, which means the place where it draws is actually off of the viewable portion of the canvas. So if we actually did want it at the bottom right of the canvas, we have to subtract by our width and height. Also, let me also label the width and height, by the way. So yes, so now if we want to see it, we need to subtract 200, the width from x, which gets us 300, and then y would also be 300, in order for us to see this square in the bottom right. Okay. All right, let's see what Waikit did next. So he moves the rectangle around, giving it different widths and heights. All right, so now question for you, you viewer at home. If we wanted to put the square, or a square of some size on the top right corner of this canvas, so top right, that would be over here. You can choose a size that you want, a width and height. It's just, I'm saying a square. The width and height would be the same. Let's say 100 pixels. So what line of code, what coordinates would you supply fill rect in order to put the square at the top right of this canvas? I will give you a couple seconds to think about it, or you could just pause the video if you would like more time to think about it. Okay, so if you did that, congratulations, you have done a valuable mental exercise. It'll help you learn whatever we're doing here. But if you just want to enjoy the show, the answer is 400 context fill rect 400, 0, 100, 100. So 400 would be the x coordinate of where the square is going to start drawing, which would correspond to the top left corner of the square. So we basically will want to start drawing the square at this point where my cursor is, right here. And since the width of the entire canvas is 500, and we want the width to be 100, so that's 100 across there, we want to start at 400 so that this square can be visible. As for the y coordinate, since the y coordinate, we don't actually need to offset for that. It's gonna start the y coordinate at this point, which is the top edge of the canvas, which that y coordinate for that is 0. So 400, 0, 100, 100. All right, let's see what Waikit did next. So you can change the color of the rectangle by changing the context's fill style value to a color name. So I'm wondering what other colors do I have? Do I have cyan? Yes, orange. So yes, you can make this rectangle any color that you want. I believe you can also do RGB colors. Let me try that. RGB, I think 25500 probably. That is red. So yeah, so like 255, red and blue gives us yellow. Woo, color theory. Okay. All right. So that's coloring the rectangle. Okay, looks like Waikit is gonna put squares on each corner. Each square having a different color. That's pretty cool. Oh, okay. So Waikit has changed this method call from fill rect to the stroke rect method, which instead of filling the entire rectangle, it's actually gonna stroke an outline to make it an outline of the rectangle. Currently, we can see the stroke is in this kind of grayish color. You can change its color too by changing the stroke style as opposed to fill styles. If you want to change the color of the fill, you change the fill style variable. On the other hand, if you want to change the color of the stroke, then you change the stroke style. Okay, now another question for you, listener. How do we put this square, this stroked square, in the center of this canvas? Okay, you can pause the video again if you want to think about it. What do we need to change about these two lines of code to get this square in the center of this canvas? Remember, the size of the canvas is 500. I'll give you a couple of seconds to think about whether you want to do that. Okay, so congratulations if you did it, or if you just want to enjoy the show. If you said 300, 300, 100, 100, that is wrong. We missed it by 100 pixels. So the correct answer is context.stroke_rect 200, 200, 100, 100, because we want to tell the context about where to start drawing the square, which should be the coordinate where corresponding to the top left corner of the square right here, and that's 200 from the left edge and then 200 from the top edge down. All right, let's keep going. You can also change the width of the stroke by changing the line width property of the context, which is pretty cool. So So Waikit is doing some fancy stuff. We have this very thick border. It looks like a picture frame a little bit. He wants to do this frame in frame effect. So yeah, so by varying the thickness of the stroke and doing multiple rectangles, you can do some kind of cool effects. One thing I'm noticing here is that the width of the line, it seems like if we draw the rectangle starting at 0, 0, which is the top left hand corner of the canvas, then part of the left stroke and the top stroke get occluded. No, we don't get to see it because we can see that the bottom and right strokes are thicker, which tells me that like if we draw if the line width, the width of the line is 20 pixels thick, then we only get to see half of it here, 10 pixels here, but it's actually 20 pixels across here. So if we want to do measurements, like line things up, we actually have to subtract or adjust for half of the line width. Like if we want to see the entire stroke on the left edge or on the top edge. Yeah, so Waikit does that. So if we start drawing at pixels or location 1010, which is around here, a little bit off from the corner of the canvas, then we get to see the entire stroke. Okay, now he draws a border just inside the entire canvas, and in order for it to show the border or the stroke on the right side and on the bottom, he also had to offset for the amount of line width. So instead of doing 500 pixels, he has to subtract the line width from that. All right, so another question for you. So if we have the line width at 10 pixels currently, and we draw it at coordinate 10 and 10, we currently get this little white gap between the stroke and the edge of the canvas. What coordinates should we put the rectangle in order to eliminate this white gap? Again, you can pause the video and come up with your answer before continuing. I'll give you a couple seconds to think about that. Okay, so if you did it, congratulations. Or if you just want to enjoy the show. First, you want to subtract 5 from the position where you start drawing the square, which is half of the line width. So you start drawing from half of the line width, and then as for the width, you need to make adjustment there as well. You want to take the edge of the canvas, which is 500, and then subtract the amount of the entire line width. Okay. Next thing, so it looks like Waikit is wanting to draw this frame in frame pattern. So he makes 3 of these frames, doing some mental calculation in his head. Okay, so another viewer question for you. So if we want to keep drawing these frames all the way from the outside in using a for loop, say, maybe something like this. What is the equation for based on this loop counter variable I? Like say the current state of the picture is we have just 3 frames, so that would be 0, 1, 2. Well, I have 3 here. Let's do 4. So if it were 4 frames, how do you come up with an equation that calculates what these coordinates and width heights need to be based on I? This is a more serious question, takes more mental power. If you want to take some time to think about it, you can pause the video now. Okay, so if you did that, again, congratulations. You did some good mental exercise there. Or if you just want to enjoy the show, let's see what Waikit did. Okay, so first he calculates the x coordinate as I times 20 plus 5. Is that correct? So 20, so the width of the line, so one of these red lines is 10. So I times 20, if I is 0, then that would end up being 0. That would end up being right here. So times 20, but if I was 1, we would get 20, so which is here. Plus 5 because of that adjustment for the when it's the thickness, you actually have to add like an offset by half of the line width. So that's where the 5 is coming from. And y is actually the exact same number as x, so he just said y is x. Okay, and that seems to work for the x and y coordinates, but not for the width and height. So now he calculates the width. Let's see what equation he comes up with. Width is 500, which is the right edge of the canvas, minus I times 2, I times 20, which is the width of the red line plus this white gap here. So that's 20 times 2. Times 2 because you have to subtract an offset that's double the amount here, because you have to account for the amount of offset that is used here plus the amount of offset that's used on the right edge, and then minus this this thickness offset. Okay, and then height is also the same as the width. So that's the equation. That's pretty intense calculation here to get this. But now that we have this for loop, I should be able to trivially add more and more frames going into the center. If we increase the number of frames beyond the center, we get the this red square like covering up the white lines, the white gaps for some reason, and I'm not sure why that is. So if we take a look at the console.log, that we print out these coordinates and widths and heights in the console, and see we actually have negative heights and widths. So what is stroke rect going to do if you have a negative width and height? I'm not sure. Oh, it still draws a rectangle. That's curious. So here we're drawing a rectangle at coordinates 200, 200, which I think is probably around here, maybe. I don't know. Let me see. I'm gonna draw one that's 100 by 100. I'll make it a different color, and then this one red. Oh, okay. So 200, 200 is at here, actually. If you do a negative width and negative height, it just draws in the opposite direction. Okay, that actually makes sense. Cool. All right, let's see what Waikit does next. Okay, so next thing Waikit wants to do is generate some different colors for this frame. So he makes an array of color names, and then he's gonna use the math random function to pick randomly one of the colors from this array. So math.random should give you a number that's between 0 and 1. If you stretch that out, multiply it by the number of colors we have, which is colors.length, and then math.floret, which chops off the decimal number, you should get a valid index for use with this array, which should randomly pick one of these colors in a uniform distribution. So using this index, we can pick a color. Oh god, okay, wow, that's some crazy color here, and every time I refresh I will get a different pattern. So very cool. Okay, so that's where I want to stop this show. I hope you enjoyed it, and I hope to have another video about Canvas for you to watch soon.